So this is a lecture to give an example of the simplex tableau method for solving a linear programming problem. And I'm going to start by going through a problem which is in the book, which is the problem that's based on the Windor glass company problem. So in this problem, we have the objective function z equal to 3x1 plus 5x2, and we have the constraints x1 less than or equal to 4, 2x2 less than or equal to 12, and 3x1 plus 2x2 less than or equal to 18, together with the non-negativity constraints. The decision variables x1 and x2 are both non-negative. So we start by introducing slack variables to convert the inequalities to equations. So we have x1 plus x3 equals, oops, sorry. This is x1 less than or equal to 4, not x4. Excuse me. So x1 plus x3 is 4. 2x2 plus x4 is equal to 12, and 3x1 plus 2x2 plus the slack variable x5 equals 18. And I also want to take our objective function and bring the right-hand side to the left-hand side. So I'm going to write this as z minus 3x1 minus 5x2 equals 0. And the table or the matrix or the tableau that we associate with this is we basically write down the coefficients of all the variables in a separate line, and we don't need to write the variables. So we're going to have columns for let's see. Let me sure I can see if I can get this all in. Z x1, x2, x3, x4, x5, and the right-hand side. And so the objective function equation, I'll call that equation 0. You have 1 times z minus 3x1 minus 5x2, and the coefficients of x3, x4, x5 in this equation are all 0, and the right-hand side is 0. This will be a line 1, equation 1, or line 1. Coefficient of z is 0. Coefficient of x1 is 1. Coefficient of x2 is 0. Coefficient of x3 is 1. Coefficients of x4 and x5 are 0. On the right side is 4. Now in this numbering, this is 0, 1, 2, and 3. So from the second equation, the coefficients of the variables are 0, 0, 2, 0, 1, 0. 0, 0, 2, 0, 1, 0, and the right side is 12. And in the third equation, the coefficients are 0, 3, 2 for 3, 4, and 5, 0, 0, 1, and the right side is 18. So this is the equation. And we also have in each equation a basic variable. So when we start, the non-basic variable, the non-basic variables will be the decision variables, x1 and x2. So for example, in this line, we have x1 and x3. x1 is non-basic. The basic variable is x3. In this equation, x2 is non-basic, x4 is basic. In this equation, x1 and x2 are non-basic, x5 is basic. And in this equation, z is basic. So this is our starting tableau. And we want to maximize z. We want to choose x1 and x2, satisfying the constraints to maximize z. And we look at the z equation, equation 0, and see if there are any negative coefficients. Well, there are, this one and this one. And we look for the most negative, which is -5. So we're going to increase the variable x2 to increase z. So x2 you put a box around this column. This is the pivot column. And for all the non-zero numbers in this, all the positive numbers in this column, we take the ratio of the right side number to the coefficient of the variable x2. So that is 12 over 2, which is 6. And here we take the ratio of the right side to the variable for x2, 18 over 2, which is 9. And we look for the smaller of these numbers, and the smallest ratio is 6. So this row will be our pivot row. And this number right here, that's our pivot number. We're going to pivot in the language of the subject. We're going to pivot around that number. So the first thing and as we do this, x2 will become a basic variable and x4 will become a non-basic variable. So x4 is leaving as a basic variable and x2 is entering as a basic variable. So what do we do next? Well, I want this pivot number to be a 1. So this equation, if I multiply it by a half, this number becomes a 1. So let me just move this up so it's visible on the screen. So this is a new tableau, but I'm keeping the same column structure. So this will be equation 0, 1, 2, and 3. So in equation 2, I want the pivot number to be a 1. I can multiply an equation by a half and not change the solutions. But if I multiply each coefficient by a half, I get 0, 0, 1, 0, 1/2, 0, 6. And then I want to get all the other numbers in this column to be 0. Well, of course, column 1 already has a 0, equation 1 already has a 0. So, and in this, x2 will be the new basic variable. Good. And x4 will be non-basic. So there already is a 0 here. So for equation 1, I don't have to change anything. It's still 0, 1, 0, 1, 0, 0, 4. And x3 is the basic variable there. To get a 0 here, I can multiply this row by 2 and subtract it from this, or what's the same thing? Subtract row 2 from row 3. 0 minus 0 is 0, 3 minus 0 is 3, 2 minus 2 is 0, 0 minus 0, 0 minus 1, 1 minus 0, 18 minus 12. So this is now 3, 0, 0, minus 1, 1, 6. And finally, I want to get a 0 here. So I add, and again, in this row, we haven't changed the variables. The basic variable is still x5. I multiply 5 times this row, line 2, to line 0. So 5 times 0 plus 1 is 1. 5 times 0 minus 3 is minus 3. 5 times 1 minus 5 is 0. 5 times 0 plus 0 is 0. 5 times a half plus 0 is 5 halves. 5 times 0 plus 0 is 0. And 5 times 6 is 30 plus 0 is 30. So this is my tableau after I've done one iteration of the simplex method. These are the right-hand sides. And again, I look to see whether there's a negative coefficient in the 0, and there is. It's minus 3. So the column where you have the minus 3 is the new pivot column. And I have 2 positive elements. If I take 4 over 1, that ratio is 4. If I take 6 over 3, that ratio is 2. That's the minimum. So this column, so this row is my new pivot row, and this is my pivot number. So I'm going to multiply this row by a third to make this a 1, and then do whatever is appropriate to get zeros here and here. So let me do that. I'll still try to keep everything in sight. So this is my Z column, X1, X2, X3, X4, X5. This is the right side. Equation numbers 1, 2, 0, 1, 2, and 3. Now, of course, if I add the pivot row to the 0, I'll get a 0 right away. So let me just do that. 0 plus 1 is 1. 3 minus 3 is 0. 0 plus 0 is 0, 0 plus 0 is 0, minus 1 plus 5 halves is 3 halves, 1 plus 0 is 1, and 6 plus 30 is 36. Let me take my pivot row and multiply by a third. I get 0, 1, 0, 0, minus the third plus a third, 2. Here I already have a 0 in row 2. I don't have to change that. 0, 0, 1, 0, a half, 0, 6. And to get a 0 here, I subtract this. I take this row minus this row. So 0 minus 0 is 0. 1 minus 1 is 0. 0 minus 0 is 0. 1 minus 0 is 1. 0 minus a third is plus a third. 0 minus a third is minus a third. And 4 minus 6. Sorry. I'm taking this row minus this row. So 0 minus 0 is 0. 1 minus 1 is 0. 0 minus 0 is 0. 1 minus 0 is 1. 0 minus a third is plus a third. 0 minus a third is minus a third. And 4 minus 2 is 2. And what are the basic variables? So here, x1 replaces x5 as a basic variable, and x3 and x2. So the basic variables are x1, x2, and x3. The non-basic variables, the ones set to 0, are x4 and x5. If we look at these equations, if x4 and x5 are 0, this says that x3 equals 2. In this equation, if x4 and x5 are 0, this says x2 equals 6. In this equation, if we said x4 and x5 equal to 0, x1 equals 2. So we have our solution. X1 is 2, x2 is 6. These are the decision variables. And our maximum profit, Z, is equal to 36. That is, oops, yeah, that is the end of the problem. Right? Setting x4 and x5 equal to 0, we get x3 is 2, x2 is 6, x1 is 2, and Z is 36. So our maximum profit is 36. That's the simplex tableau. Now, okay, so for this talk, I'll stop here. And in the next couple of lectures that I post, I'll be solving the homework problems that are due today.